Hello, I am Alexander, an embedded C++ developer at Droid Technologies. I specialize in firmware development for different microcontrollers, how bare metal or RTOS based. In this video, I would like to discuss an important topic – measuring battery capacity in rechargeable lithium batteries. In many designs that incorporate rechargeable batteries, battery capacity is often estimated by measuring voltage. However, this approach is inaccurate because battery voltage is not directly proportional to capacity and will depend on the load. The correct method is to calculate the charge flowing in and out of the battery, measured in coulombs. In our project, we use a battery fuel gauge, also known as a battery gas gauge. It is a feature or device that precisely measures the accumulated energy added to and removed from the battery. In our video, we will use BQ28Z610 battery fuel gauge. Before using it in a real device, we need to create a golden image and upload it. To create a golden image, we will use BQ28Z610 development board based on our fuel gauge, EV2400 USB to I2C adapter board to connect our fuel gauge board and the PC, BQ Studio tool to create our golden image, electronic load, a torch DL24MP for the controlled discharge current, our battery and charger that will be used in the final product. Connect the battery intended for the final product to the battery fuel gauge development kit and then connect it to the interface board. Ensure all connections are established with the PC. Launch BQ Studio and configure the initial settings for the current battery, capacity, chemical ID, and so on, and perform accurate calibration of the battery's voltage and current. Connect an electronic load to the battery fuel gauge development kit, which is already connected to the battery. In this step, we begin training the battery fuel gauge to generate the golden image. Ensure the battery is not fully discharged, and the first step is to discharge it. First, discharge the battery using the connected load. Once discharged, disconnect the electronic load and allow the battery to rest for 5 hours. Next, connect a charger instead of the load and fully charge the battery. After reaching full charge, disconnect the charger and let the battery rest for 2 hours. Reconnect the electronic load and discharge the battery fully again. Once discharged, disconnect the load and wait for 5 another hours. After completing these steps, generate the golden image, which can be uploaded to other fuel gauges using the same battery model. This training process could take even a few days. The process of creating golden image is a complex process, how any embedded development. At Droid Technologies, we are here to assist you with embedded design project of the electronics, firmware, software and mechanical design, ensuring successful implementation and optimal performance.